Hello and welcome to our discussion of Chapter 5, Prepare for Assessment in ISOL 536, Security Architecture and Design. My name is Dr. Alan Dennis. I'm your lecturer, and I'll be discussing this topic with you today. Here's the outline of Chapter 5, which we'll be going over today. We'll start by discussing the process review. Then we'll move on to architecture and artifacts, threat enumeration, attack surfaces, data sensitivity, and some few additional thoughts on risk. We'll talk a little bit about possible controls, and then we'll conclude with the summary. So to kind of state the context and start off with a bit of a summary, in the past we've talked about how information assurance is achieved when information and information systems are protected against attacks through the application of security services such as availability, integrity, authentication, confidentiality, and non-repudiation. We go on and talk about how the application of these services should be based on the protect, detect, and react paradigm. So what this means is, in the context of Chapter 5, is that in addition to incorporating protection mechanisms, organizations need to expect attacks and include attack detection tools, procedures that allow them to react and recover from those unexpected attacks. So they may not be totally unexpected, but you won't know when they're coming. At the highest level, as we've talked about in the past, it's about architecture, threats, attack surfaces, and mitigations. And you can see the flow graphically from left to right with architecture, threats, attack surfaces, and then mitigation. Credible attack vectors are those which we talked about in Chapter 4. They include basically three kind of subterms, which is threat, exposure, and vulnerability. Risk is it's a critical governing principle that underlies the entire risk assessment and threat model process. So ultimately, you mitigate those computer attacks that are likely to give you grief in an effort to basically protect your organization. So it's about assessing the ones which are likely and that could happen and are more likely to happen than those that might possibly theoretically happen but are unlikely. When we're applying that approach, uh, we start with this whole concept of a strategy, which is including the threat landscape and the risk posture, structures, the set of possible controls, existing security limitations, the specifications, data sensitivity, and runtime execution environments, and then we talk a bit about deployment models. So this is basically a summarization of that stuff that we just went through, and basically the three S's for convenience, not necessarily implying any kind of ordering. Um, it's important to basically take a look at the threat landscape anytime you're looking at this stuff and talk about how the system's going to be deployed and where it's going to be deployed. So drilling down into some of these things a little bit more, the architecture is going to be about understanding the logical components and architecture of the system, understanding every communication flow, and how data is moved and stored. Threats, the possible threat agents, the ultimate goals of those threat agents, the typical attack methods that they're likely to use, and the system level objectives of the threat agents using their attack methods. So what are they after and how they're going to try to get to it. Attack surfaces, basically you do this through factoring down, decomposing the architecture to a level that exposes the various levels that someone might be able to attack at. So those attack surfaces being decomposed. Apply the attack methods for the goal that they're trying to do, the expected objectives to using those attack surfaces, and then filter out the threat agents who have no attack surface exposed. So the idea is to make it to where there's less of them to be able to get through. Mitigation is a way that you're going to try to manage the risk and the potential exposure. So you're going to list out all the existing security controls. You're going to filter out the attack surfaces where there's sufficient protection. You're going to focus on those that don't have it. And then you're going to apply new security controls in the set of attack surfaces for which there isn't sufficient mitigation. So you're going to identify those things which need some additional help and add to it. And then you're going to do so in a defense in depth architecture, which is always a security best practice. Um, Keep in mind, this is what we call non-trivial. Uh, what that means, it's hard. You'll it's easy to say this stuff. It's much harder to do it. I'll say it that way. So anytime you hear somebody say something is non-trivial, that means that it's really hard, maybe even impossible. When we talk about architecture and artifacts, you need those in order to basically understand the system architecture, what the objectives of deploying the system, what's the point, what is it trying to do, and you want to do your assessment starting at the begin, determining the intended purpose. So what's the point of this thing that you're assessing, the overall goals of deploying it within the organization, and who's going to use it. This is kind of a grounding sort of effort so that you can then from there make assessments based upon what's going to go happening in the real world, and what's the intended context. The logical architecture is representing logical functions, which is kind of a self-defining sort of definition. But the basic idea is that you think about these things of conceptually or logically how they function, not so much physical. So the logical architecture could be considerably different than the physical implementation or the physical architecture, but it should be the embodiment of is the distinction. So there are generally computers, servers, and operating systems, but not necessarily detailed. This somewhat changes in the modern architectures, though, because you may not truly have a server or a computer. You may be running in a container. Logically, yeah, sure. Or at the end of the day, there really is a computer, but from your perspective as the consumer of those computing resources, there isn't really. So there's also probably going to be a network, may not be physical, but there will be a network um, that are going to be assigned to interfaces. Um, but it's not necessarily important at a logical level. And that's what we're trying to get across here is that at a physical level, you care about things like how many network interfaces there are on a given computer, what sort of operating system it's running on, what kind of computer it is, how many processors or cores it has, how much memory. You might care about all those things. Logically, you don't necessarily care. It's at a higher level, less detail, more abstract, trying to get across kind of the concept. The and basically there's going to be some sort of a network architecture tying them together. And again, at a logical level, it's not very much detail. When you get into physical, the network architecture may actually be its own thing. The logical architecture is probably a typical three-tier web architecture for a lot of the applications you're going to be dealing with. There's probably going to be some form of bidirectional authentication across trust boundaries so that not just anybody can talk to something on either direction. So there's going to be probably some sort of identity of those particular devices or systems that ensures that the right people are talking to them, the right systems are talking to them. Um, and there's going to be a certain amount of validation occurring before things cross trust boundaries. So you're going to have some sort of authentication, identification, and so on. There's probably going to be a firewall in the mix, which is where you're going to be crossing trust boundaries, if not some sort of more even advanced stuff with multifunction switches and so on, actually doing subnets and true network type controls. But you're not necessarily going to see a lot of this stuff inside of a logical architecture, but it's definitely going to be there at a physical level. You may see it a little bit, but it's not going to be near the detail. Whenever you're doing this stuff, it's important to understand where your valuable data is and how it's going to be stored. And wherever and whenever it touches like a disk, you want to know about it and you want to know how it's being stored. The simple answer is you always want it to be encryption at rest. You don't want to store anything in the clear pretty much ever. So that's one sort of concept. Um, Static content may also be stored. Generally, there's going to be things like images and so on, but that has been in the past a vulnerability, so care should be taken around that as well. It may be on a local disk running on the web server, or it may actually be someplace else. Whenever you're doing one of these sort of assessments, you want to make a list of the various types of threats that can occur, and then you start working on a prioritization of those things. And this is kind of a general pattern you're going to follow in lots of spaces, right? Is make a list, figure out the priority of various things so that you can address them in the appropriate order. So you start with listing all the possible threat agents for this type of system. So if you've got something that's a mundane set of data that's not necessarily terribly valuable, it's going to have one set of threat agents that are interested in it, maybe a very small subset of the possible ones. If you have something that has something that is valuable, social security numbers, financial information, some way of getting at money, that's going to have a totally different set of people, and they're probably going to be much more interested. This is kind of interesting to think about security researchers as threats. But it is true that most of the time, security people are going to take an interest in the security. Uh, it's not it's not something to be considered as an insult to those researchers, but security researchers are potentially a threat agent. They may have an interest in it, and it may not be just individuals. It may be organizations that their goal is to assess the overall security of a general domain, a particular industry, even. So, is something to consider. Researchers oftentimes try to find vulnerabilities, and when they find them, they typically raise them and publish it, trying to get people to take a note and fix them. That's the idea. And the basic idea here is hoping that the good guys find the problems and let everybody know before the bad guys find them. That's why you also want to stay up to date on all your patches and so on, and fixing your software is because you don't want to be running with a known vulnerability that's been published and perhaps found by somebody that is a security researcher, uh, not in a malicious way, but you do want to be fixing things to make sure you're up to date. This is basically saying that researchers are going to be, or hackers are going to be doing something uh, to with an intent. Uh, they basically work on trying to find uh, true vulnerabilities compared to true like stunt hacking. Cyber criminals are probably not going to waste their time trying to find some particular uh, new way of doing something. They're probably going to use an available tool uh, and not necessarily spend the effort themselves trying to develop something with random instructions and so on. Knowing what somebody's after is an important part of the whole thing. Um, and especially when they're going after system level of stuff. So if you're trying to get to something that runs inside of a secure location, uh, so in this case, it might be some sort of scripting code that executes in a browser that gets somehow system level privileges or something beyond what it's supposed to be able to do. That sort of vulnerabilities are bad. Um, So in general, you want to focus your energies on those things which people are likely to use, not so much something that could be used. So looking at a level of system level objectives and the threat agents that might be using it, security researchers are going to be using gadgets to basically try to find some way of getting in. They may actually be taking a look at some source code and finding something inside of the source code and then finding a way to exploit the vulnerability. So also trying to get past the no executes page policy to actually make a page turn into something sort of execution against most likely security researchers, system debugger to try to get into some sort of overflow condition. Could be cyber criminals, but most likely it's going to be researchers. So SQL and LDAP injection, yeah, cyber criminals are going to go after that because it potentially gives them access without proper authorization. Same thing with cross scripting, direct object reference, and cross-site request forgery. Similar cross-site scripting, but basically taking advantage of somebody being logged in one site and appearing to be somewhere else. And then the unvalidated requests, redirects and forwards. Again, generally speaking, cyber criminals are going to go after this stuff that there's essentially some sort of pre-existing tools that make it a whole lot easier to do, rather than spending the time coming up with something that takes an awful lot of work. So we try to come up with all the attack surfaces and categorize them, and avoid and come up with to at some point prioritize them, but not necessarily when you're listing them. So you can think of the attack surface as a brainstorm. Any discussion about legitimacy or fitness of attack surface tends to bog down the enumeration into too many details. So basically come up with your list of all the possible things and then worry about prioritizing them and rating them and filtering them later. Decomposing is a common way of addressing a problem. The idea here is that you're going to be looking for attack surfaces by starting at trust boundaries, taking a look. And this is not that dissimilar from things that you might do inside of some of the programming languages. Oftentimes, around boundary conditions is an opportunity or for a mistake or an error. The same thing with having something that isn't intended to be something. So the idea here is you want to take a look at boundaries and where things are crossing those boundaries, because it's a potential vulnerability as something could come into that or out of that environment that's not expected. So um, here's kind of an example of the web server and the various boundaries that are involved, and um, the typical three-tier architecture. Um, the three-tier architecture to some extent is also evolving to more of a almost two-tier architecture, or the application and database distinctions. The database is still its own thing. The web server versus the application server is less prevalent today than it once was. It still exists in the Java world, not so much in the .NET world, because most of the time now web servers are actually running the application logic in some capacity. But regardless, this pattern and paradigm you'll still see. So here we're seeing an additional error that points to the most obvious attack surface, so the web server. It would make sense that's going to be the thing that is the most exposed and also get the most attention. So they're basically going to go through and periodically do a port sweep on it, probing to see if there happens to be something open, uh, hoping that you left something open or whatever that wasn't intended to be, and perhaps did something foolish like exposed SSH or something without a password, which would be really bad. But that's the idea, is it's going to get most of the attention. And obviously that's where you would also want to focus most of your attention, is the place that's getting the most attacks or the most probing. Uh, Injections downstream can occur, LDAP in databases and at application servers. They can still occur, but there are frameworks in place now that help you avoid things like cross-site request forgery unless you purposely turn off those checks. Crossing domain boundaries with web pages is generally, there's systems that automatically stop that from happening. You can mitigate this stuff at various layers with various approaches. The best approach is to utilize a coding framework that has the support to handle this stuff built in, rather than having to build it yourself, or making sure that your developers are using one that does. This is a list of the various types of attacks that might be involved, what they're trying to accomplish, what the attack surface is going to be. A lot of these are going to be HTTP, and then who might be interested in it. And if you get past most of this stuff, it's going to be your cyber criminals. They're going to be interested in things like the LDAP and SQL inject, the cross scripting side, and so on. And part of that's going to be because those sort of resources exist and are available to them in some sort of a dark net or black market sort of environment. Filtering out the threat agents that have no attack surface exposed is a good way. So you're basically going to figure out that there's some people that are not going to be able to get to certain things, then you can eliminate that stuff. And that's part of the benefit of having a defense in depth, is to try to filter things out. You still don't necessarily ignore it, but if you've addressed the likelihood of getting past it, you can focus your attentions elsewhere. You want to start listing out all of the existing security controls for each attack surface. So what stuff has already been implemented to try to address the various vulnerabilities, because it's already been addressed. If it's done so in a sufficient way, there's no reason for you to readdress it again, right? So focus your energies on those things which need to be addressed, not which has already been addressed. Don't revisit unless it's been a sufficient amount of time. You don't really need to revisit things that have just been addressed. And that's pretty much what this is saying, as well as filter out attack surfaces for which there's sufficient existing protection. So there's already enough stuff in place. You deem it to be adequately protected, then you can move on to things which are not. Again, filtering out some of these things. Um, you can filter out things like LDAP and SQL injection through frameworks, um, and especially if you do so where you would never want something that's generating SQL at the web server front end to pass it uh, in an unstructured way to a database server. That's the most common way that would occur. So you would stick something onto the end of it that basically caused another command to be executed. And that was, generally speaking, because people were being relatively lazy with their code. So the basic idea here is to filter those out that have already been addressed. We talked in the past about data classification. Part of that is so that you can assess the risks associated with a particular vulnerability. If the database that you're trying to protect contains non-important information that maybe you wouldn't, it's not the end of the world if it gets exposed. So maybe it's not identifying, so there's no information about who's involved with it. And maybe it's some sort of transactional information that doesn't mean anything without having some more information associated with it. You don't want to spend a whole bunch of time trying to protect it. You want to focus your energies on those things that have a higher sensitivity, be it something that is more expensive if it were to be leaked, or something that could do damage to the firm if it were to be released. So the basic idea here is that you want to, during that risk calculation, uh, you want to keep things away from the stuff that is the most important. You want to make sure that that the risk treatment is affordable and doable. You can't really do it all, so to speak, because there's some things that the return on investment simply isn't there. And that's one of the things that you probably need to do, is think of it in terms of that. How much money is an organization willing to spend to protect something, and what is the cost associated with failure to do so? And if it turns out that it's less expensive to not protect it, then you may not protect it. So there's lots of different ways of doing controls. Um, but the biggest thing is to try to make sure that you get rid of fraudulent and fake accounts, make sure that there's reasonable things. That's part of the reasons why you'll see a lot of firms have these Captiva type stuff where you have to enter in words and so on to identify that you're a human versus some sort of script that's trying to gain access. It's all about attempting to keep out fraudulent accounts and fake accounts and keep it to be actual people. So whenever we're looking at applying new security controls to the set of attack surfaces for which there isn't sufficient mitigation, this is what I've been talking about all along. Of you spend your energy on those things where there isn't something in place to protect it. SQL injection might be something. If a person had a website that didn't have any kind of things in place to protect it, you would definitely want to avoid dynamic input from users going directly into something that is a query string. It should be something that is inserted into a very rigid sort of structure and inspected perhaps to make sure that it doesn't contain anything that's not appropriate. Um, Again, most coding frameworks that are modern and in use today have automatic controls in place to avoid that. And the reason being is it is something that is potentially pretty challenging, but it's also pretty easy to address with a robust framework. Defense in depth is going to be a reoccurring theme, as I've mentioned in the past. You want to make sure that you're having various layers uh, of controls in place along the way, using something like the transport layer security. Typically over something like HTTPS is a good way to do so. It's reducing the chance of somebody doing something unexpected or accessing the website in an unexpected way. It also is a way of ensuring that data is encrypted in motion when it's going across the web. So it's a very good reason to be using it. Also, um, you want to make sure that anytime it is stored somewhere, uh, persisted to disk in some fashion, that whatever the media that it's actually being written to, that there's encryption involved, database or whatever, make sure that it's encrypted when it actually touches that disk. So to summarize the things we've talked about, um, you in a real world sort of discussion, it's about return on investment of the effort that you spend whenever you're prioritizing, assessing, and determining where you should spend your efforts to manage and mitigate the various risks associated with a given implementation. And with that, I will conclude. Feel free to reach out to me if you have any questions. That's what I'm here for. Stay safe, and I'll talk with you next week.